Today's lecture is Chapter 7 about blockchain. Blockchain, sometimes referred to as distributed ledger technology, DLT, makes the history of any digital asset unalterable and transparent through the use of decentralization and cryptographic hashing. A simple analogy for understanding blockchain technology is a Google Doc. When we create a document and share it with a group of people, the document is distributed instead of copied or transferred. This creates a decentralized distribution chain that gives everyone access to the document at the same time. No one is locked out awaiting changes from another party, while all modifications to the doc are being recorded in real time, making changes completely transparent. This slide shows the learning objective of this topic. Firstly, the objective to explore the big picture of blockchain technology and architecture. Secondly, to understand the usage of blockchain technology as public ledger. And lastly, to differentiate blockchain and smart contract. This slide shows contents of blockchain topic. Firstly, a start with differentiation between blockchain and Bitcoin. Secondly, blockchain network, then smart contract, the fifth computing paradigm of blockchain, then technology hype cycle, and end up with mining and minting. What is Bitcoin? Bitcoin is kind of digital cash, which a digital currency and online payment system in which encryption techniques are used to regulate the generation of units of currency and verify the transfer of funds, operating independently of a central bank. Bitcoin was created in 2009, which released on January 9, 2009 from unknown person or entity using the name Satoshi Nakamoto. BTC relies on a blockchain as the proof of all transactions. Most people who have heard the term think that the blockchain is only something to do with cryptocurrencies such as Bitcoin, Litecoin, Dogecoin and others. It's the technology that underpins digital currencies and ensures that all transactions are properly conducted and recorded. But what is stored on the blockchain need not be just a currency unit, it can be put to all manner of other interesting uses. The blockchain is defined as a system that's secure without a higher authority, distributed across many strangers' computers, yet tamper-proof, and promises a mechanism for trust mediated directly between individuals. Essentially, by providing a distributed means to guarantee and verify transactions, the blockchain offers the ultimate opportunity to cut out the middleman. A key aspect is the programmable smart contract, code stored on the blockchain that automatically executes when certain conditions have been met. In uses that involve a financial transaction, it makes sense to use Bitcoin or some other digital currency for the same reason. By doing so, transactions can be automated and guaranteed without recourse to third parties, such as a bank. Not all uses involve payments. For example, Kim Jackson and Zach Lobo were married on the blockchain in November. Is a blockchain marriage legally binding? Well, some parts of it would fall within contract law, but it's a first symbolic step. In other cases, the blockchain can be used for peer-to-peer exchange or sale. Imagine you have an electric car. When your charger is unused, you can rent it out to other car owners, paid in bitcoins via a blockchain smart contract. This slide shows the process for blockchain transaction example using Coinami wallet. This detailed guide will show you how to exchange coins on Coinami. First, open your Coinami wallet application. Then select coins you want to exchange from the sender wallet. Specify the amount of a coin you wish to be transferred to receiver address. Then scan QR code for transaction. Click Send for finished transaction. Meanwhile, this slide shows confirmation of transaction. You can check the list of transaction as shown in the left figure. You can also check the detail of transaction and public key for each transaction as the following figure. This slide is about blockchain overview. Blockchain is a growing list of records, called blocks. Each block are connected or linked using secure cryptography algorithms. Blockchain is either a decentralized or distributed digital ledger to record transactions. Record cannot be altered, without the modification of all subsequent blocks. This slide explains on what is Bitcoin blockchain. Bitcoin blockchain is public ledger list of all Bitcoin transactions that have ever been executed. It constantly growing as miners add new blocks to it, every 10 minutes, to record the most recent transactions. The blocks are added to the blockchain in a linear, chronological order. Each full node, for example, of every computer connected to the Bitcoin network using a client that performs the task of validating and relaying transactions, has a copy of the blockchain, which is downloaded automatically when the miner joins the Bitcoin network. The blockchain has complete information about addresses and balances from the Genesis block, the very first transactions ever executed, to the most recently completed block. A blockchain is a growing list of records, called blocks, that are linked using cryptography. Each block contains a cryptographic hash of the previous block, a timestamp, and transaction data, or generally represented as a Merkle tree. By design, a blockchain is resistant to modification of the data. It is an open, distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. For use as a distributed ledger, a blockchain is typically managed by a peer-to-peer network collectively adhering to a protocol for internode communication and validating new blocks. Once recorded, the data in any given block cannot be altered retroactively without alteration of all subsequent blocks, which requires consensus of the network majority. Although blockchain records are not unalterable, blockchains may be considered secure by design and exemplify a distributed computing system with high Byzantine fault tolerance. Decentralized consensus has therefore been claimed with a blockchain. From the figure it shows the main chain in black color consists of the longest series of blocks from the Genesis block, which green in color to the current block. Orphan blocks in purple exist outside of the main chain. Ethereum Improvement Proposals, or EIP, describe standards for the Ethereum platform, including core protocol specifications, client APIs, and contract standards. We will explain all those params, one by one. Let's start with an exciting part. Config is not a required param and we can remove it from Genesis.json, but we added it in this example to let you know that it exists. If you are creating your private blockchain, you don't need the last three params, so just set them to 0. The first param chain it is a unique identifier of the chain, so you can set it to any number, or just leave it as 0. Nonce is a 64-bit string hash. This string is used in combination with Mike's hash. Since Ethereum uses proof of work, it's used to prove that a sufficient amount of computation has been carried out on this block. Both of them combined must satisfy the mathematical condition described in the yellow paper, in the paragraph describing block header validity. According to that paper, the mining proof of work exists as a cryptographically secure nonce which proves, beyond reasonable doubt, that a particular amount of computation has been expended in the determination of some token value n. Timestamp is, according to the Ethereum paper, the timestamp is a scalar value equal to the reasonable output of Unix's time at this block's inception. It's used for the mechanism that enforces homeostasis in terms of time between blocks. If the time difference between two blocks is small, the difficulty level increases. If that happens, additional computation will be required to find the next valid block. Otherwise, the difficulty will decrease if the time difference between two blocks is too big. Timestamp param is used to modify difficulty if needed. Parent hash is the kekak 256-bit hash of the parent block's header. That is kinda a pointer to the parent block needed to form a real chain of blocks. For those familiar with programming, it's similar to the linked list mechanism. A Genesis block has no parent block, so the result will, only in this case, be equal to 0. Extra data is an arbitrary byte array containing data relevant to this block. Also, it's an optional param which can't be bigger than 32 bytes. Gas limit is a scalar value equal to the current limit of gas expenditure per block. Transactions also have gas limit param, and we have to be aware that a sum of gas limits of all transactions in the block must not be greater than the block's gas limit. Difficulty is a scalar value corresponding to the difficulty level of a particular block. For blocks this can be calculated from the previous block's difficulty level and a timestamp, but in this case we don't have previous blocks, so the difficulty has to be defined. The purpose of the difficulty level is to control the block generation time of a blockchain, to keep block generation frequency within range. If the difficulty is high, miners have to perform more calculations, while lower value means that miners have to perform fewer calculations to validate a block. Mix hash is 256-bit hash which, combined with the nonce, proves that a sufficient amount of computation has been carried out on the block. Coinbase is a 160-bit Ethereum address where all rewards collected from the successful block validation will be transferred. A reward is a sum of the mining reward and the refunds from executing contract transactions. Since it's a Genesis block, the value for this block can be anything. For all the next blocks the value will be an address set by the miner who validated that block. A lock is used to pre-fund some ETH addresses. It contains two parameters, the address that has to be 160-bit hash and the number of ETH with which an account should be funded. Graphic of data fields and Bitcoin blockchain is shown in this slide. Simplified depiction, some fields are missing. Prev_hash, hash value of previous block. The purpose is to chain all blocks together. Tx_root, root hash value of a hash tree, W Merkle tree, over all transactions. Timestamp, creation time of block, as seen by block creator. The timestamp is checked by other clients and must be within a certain window, tolerates small clock skews. Nonce, any number to make sure the resulting hash value of this block is below the target hash value. The nonce is a 32-bit number and the 232 number space is exhausted during mining within less than a second. The transactions, TX0, TX1, are appended to the block. The first transaction generates new bitcoins and contains the Coinbase field which includes an extra nonce to provide a larger search space for valid block hash values. This slide shows the blockchain header for Bitcoin. This block headers are serialized in the 80-byte format. Hashed as part of Bitcoin's proof-of-work algorithm. Serialized header format is a part of the Bitcoin network consensus rules. This slide shows the Merkle tree. Merkle root is the hash of all the hashes of all the transactions in the block. To securely verify that a transaction has been accepted by the network, and get the number of confirmations, by downloading just the tiny block header's entire blockchain is unnecessary. Merkle tree creates a single value that proves the integrity of all of the transactions under it. This slide shows the blockchain security. Blockchain protected data and information using secure encryption algorithms such as 256. Blockchain protect integrity of data and information using SHA-256 or SHA-3. Blockchain protect confidentiality by allowing only the owner of data or information can access to blockchain network. Example integrity using SHA-256. Transaction 0. A long transfer RM1 to Busu, the unique hash number generated. A long transfer RM10 to Busu, the other unique hash number generated. The same happened for transaction 1. This is an example of Blockchain Explorer for Bitcoin. You can see the latest block after transaction and the age of transaction. Can see also the hash number and value out for each hash as in figure. You can also explore for each hash block detail. You can find the number of transaction, height, block reward, timestamp, mined by, Merkle root, previous block, difficulty, bit sizes, Versia and it nouns. As you do compare with block number 0. It gave different number of transaction and other detail as compared with previous slide. This slide shows the other blockchain explorer websites. You can use other websites such as Bitcoin from blockexplorer.com. Zcash website, zcash.blockexplorer.com and Ethereum, etherscan.io. Blockchain also can be defined as any currency, financial contract, or hard or soft asset may be transacted with a system like a blockchain. Blockchain may be used not just for transactions, but also as a registry and inventory system for the recording, tracking, monitoring, and transacting of all assets. Blockchain is quite literally like a giant spreadsheet for registering all assets, and an accounting system for transacting them on a global scale that can include all forms of assets held by all parties worldwide. This slide explains about how a cryptocurrency works. The Bitcoin value chain is composed of several different constituencies: software developers, miners, exchanges, merchant processing services, web wallet companies, and users, consumers. From an individual user's perspective, the important elements in transacting coin are an address, a private key, and wallet software. The address is where others can send Bitcoin to you. The private key is the cryptographic secret by which you can send Bitcoin to others. Wallet software is the software you run on your own computer to manage your Bitcoin. There is no centralized account for you to register. If you have the private key to an address, you can use that private key to access the coin associated with that address from any internet-connected computer, for example smartphones. Network topologies for cryptocurrency can be in form of centralized, decentralized and distributed. In terms of security and trust, cryptocurrency can say as a trustless proof of all the transactions on a network. Users can trust the system of the public ledger stored worldwide on many different decentralized nodes maintained by miner accountants, as opposed to having to establish and maintain trust with a transaction counterparty, which is another person or a third-party intermediary, like a bank. Then, blockchain as the architecture for a new system of decentralized trustless transactions is the key innovation. The blockchain allows the disintermediate and decentralization of all transactions of any type between all parties on a global basis. This slide about blockchain versions. Version 1.0, Currency, the deployment of cryptocurrencies and applications related to cash, such as currency transfer, remittance, and digital payment systems. Version 2.0, Contracts, the entire slate of economic, market, and financial applications using the blockchain that are more extensive than simple cash transactions, stocks, bonds, futures, loans, mortgages, titles, smart property, and smart contracts. Version 3.0, Blockchain applications beyond currency, finance, and markets, particularly in the areas of government, health, science, literacy, culture, and art. This slide explains about disruptive computing paradigms. Mainframe, it started in 1970s. For PCs in 1980s. Internet in 1990s. Social mobile started in 2000s and blockchain started 2010s. The importance of blockchain technology is even U.S. Congressman has introduced bills supporting with blockchain and cryptocurrencies technology as announced by U.S. Representative Tom Emmer in September 2018. This slide shows about smart contract. Smart contract is direct exchange money, property, shares, or anything of value in a transparent while avoiding the services of a middleman or trusted third parties. Definition: An asset or currency is transferred into a program and the program runs this code, and at some point it automatically validates a condition and it automatically determines whether the asset should go to one person or back to the other person, or whether it should be immediately refunded to the person who sent it as stated by Vitalik. Smart contracts will refer to blockchain ledger as a proof of a mutable transaction. Smart contract also allows programmers to create applications and smart contracts that utilize computing power from Ethereum's network to execute them. While smart contracts might sound new, the concept is rooted in basic contract law. Usually the judicial system adjudicates contractual disputes and enforces terms, but it is also common to have another arbitration method, especially for international transactions. With smart contracts, a program enforces the contract built into the code. Quoted from U.S. Senate Report, 2018. For smart contract programming is normally using Solidity programming, which was initially proposed in August 2014 by Gavin Wood. Later this programming language was developed by the Ethereum project's Solidity team, led by Christian Rehuesnor. It developing smart contracts that run on the Ethereum Virtual Machine, EVM. Development IDE using Remix, which official from Solidity IDE, Microsoft Visual Studio. Web Edge Library, APIs, is for interaction with a deployed smart contract. Web Edge Android Library, APIs, is for interaction with a deployed smart contract using Android Studio. Meanwhile, Web3.Swift is for iOS development. This slide shows an example of smart contract using Solidity coding. Meanwhile, this slide shows an example of smart contract using Go Ethereum. This slide shows the application of smart contract or blockchain. It can be applied at purchasing goods through online trading portal, for example Lelong.com. Cashless system. Order and payment contract, for example buy new car, house. Online voting system to prevent double voting, which can get one vote or token only. This slide shows an example of e-voting system without blockchain. This slide shows cryptocurrency mining. Mining is a process of validating a transaction or block in a network. It using complex algorithms, for example hashing SHA-256, to prove and validate the correctness of the transaction and thereby add the new block to the chain. Bitcoin mining is often thought of as the way to create new bitcoins as secondary purpose. The primary purpose of mining is to ensure that all participants have a consistent view or consensus of the Bitcoin ledger. Bitcoin ledger is a distributed peer-to-peer system. There is no central database that keeps track of who owns bitcoins. Instead, the log of all transactions is distributed across the network. The main problem with a distributed transaction log is how to avoid inconsistencies that could allow someone to spend the same bitcoins twice. POW or POS. Proof of work versus proof of stake. Recently you might have heard about the idea to move from an Ethereum consensus based on the proof of work (POW) system to one based on the so-called proof of stake. In this article, I will explain to you the main differences between proof of work versus proof of stake, and I will provide you a definition of mining, or the process new digital currencies are released through the network. Proof of work is a protocol that has the main goal of deterring cyber attacks such as a distributed denial of service attack, DOS, which has the purpose of exhausting the resources of a computer system by sending multiple fake requests. The proof of work concept existed even before Bitcoin, but Satoshi Nakamoto applied this technique to her. We still don't know who Nakamoto really is. Digital currency revolutionizing the way traditional transactions are set. But, returning to date, proof of work is maybe the biggest idea behind the Nakamoto's Bitcoin white paper, published back in 2008, because it allows trustless and distributed consensus. Going deeper, proof of work is a requirement to define an expensive computer calculation, also called mining, that needs to be performed in order to create a new group of trustless transactions, the so-called block, on a distributed ledger called blockchain. Mining serves as two purposes. Firstly, to verify the legitimacy of a transaction, or avoiding the so-called double spending. Secondly, to create new digital currencies by rewarding miners for performing the previous task. When you want to set a transaction, this is what happens behind the scenes. 1. Transactions are bundled together into what we call a block. 2. Miners verify that transactions within each block are legitimate. 3. To do so, miners should solve a mathematical puzzle known as proof of work problem. 4. A reward is given to the first miner who solves each block's problem. 5. Verified transactions are stored in the public blockchain. From a technical point of view, the mining process is an operation of inverse hashing. It determines a number, nonce, so the cryptographic hash algorithm of block data results in less than a given threshold. This threshold, called difficulty, is what determines the competitive nature of mining. More computing power is added to the network. The higher this parameter increases, increasing also the average number of calculations needed to create a new block. This method also increases the cost of the block creation, pushing miners to improve the efficiency of their mining systems to maintain a positive economic balance. Proof of stake will make the consensus mechanism completely virtual. While the overall process remains the same as proof of work, POW, the method of reaching the end goal is entirely different. In POW, the miners solve cryptographically hard puzzles by using their computational resources. In POS, instead of miners, there are validators. The validators lock up some of their ether as a stake in the ecosystem. Following that, the validators bet on the blocks that they feel will be added next to the chain. When the block gets added, the validators get a block reward in proportion to their stake. In a distributed consensus based on the proof of work, miners need a lot of energy. One Bitcoin transaction required the same amount of electricity as powering 1.57 American households for one day, data from 2015. Meanwhile, in proof of stake, forgers are always those who own the coins minted. Thanks to a POS system, validators do not have to use their computing power because the only factors that influence their chances are the total number of their own coins and the current complexity of the network. So this possible future switch from POW to POS may provide the following benefits. 1. Energy savings. 2. A safer network as attacks become more expensive. If a hacker would like to buy 51% of the total number of coins, the market reacts by the fast price appreciation. This slide shows the example of mining algorithms. There have many of them and some of them obsolete and some still remain. This slide shows an example of real mining farm in Malaysia. Following are the merchant-accepted Bitcoin, BitPay and Coinbase in the United States, BitPay and Coinbase in the United States and Luno in Malaysia/Indonesia/Singapore, for example Bitcoin exchange BTC to Ringgit Malaysia. This slide shows the Bitcoin blockchain size. The size is increased from time to time, which you can refer from charts.bitcoin.com web link. Anyone is able to run an Ethereum node on their computer. This means that you can participate in validating transactions and blocks on the Ethereum blockchain. The two most common clients for running nodes are Geth and Parity. Depending on the type of node run and the hardware specifications of the system, the initial synchronization time and storage requirements vary. For information related to the current full node chain data and state storage size, check out etherscan.io web link. For hardware part, this information should be considered. A consumer-grade laptop will be enough to run a full node, but not an archive node. An archive node does need 2+ TB of disk space, and that disk space cannot be HDD, it must be SSD for both full and archive nodes. Light nodes run fine on SD cards and HDDs. If a full node goes offline for a while, its data can get corrupted and it can take a while to restore it. For best results, if running your own node, run it on an always-on always connected device for minimal downtime and maximum reliability. This can be impossible on a laptop and expensive on a desktop PC, 500 watts plus, so it's better to use a device that's cheap to build and replace and almost free to run. Our 2018 Hype Cycle reveals 5 emerging technology trends that profoundly shift experiences in our spaces, blur the lines between human and machine, and enable AI ubiquity that will propel organizations to connect into new business ecosystems to become competitive over the next decade. On the rise Hype Cycle are included: biotech on cultured or artificial tissue, flying autonomous vehicles, smart dust, artificial general intelligence, 4D printing, knowledge graphs, neuromorphic hardware, blockchain for data security, exoskeleton, edge AI, autonomous driving level 5, conversational AI platform, self-healing system technology, volumetric displays, 5G, quantum computing. At the peak of Hype Cycle are AI PAs, deep neural network ASICs, smart robots, autonomous mobile robots, brain-computer interface, smart workspace, biochips, digital twin, deep neural nets, deep learning, carbon nanotube, IoT platform, virtual assistants, silicon anode batteries, blockchain. Meanwhile, sliding into the trough are connected home, autonomous driving level 4, mixed reality, smart fabrics, augmented reality. The 2019 Hype Cycle highlights the emerging technologies with significant impact on business, society and people over the next 5 to 10 years. This year includes technologies that promise to deliver a global low-latency internet, create a virtual map of the real world and mimic human creativity. On the rise Hype Cycle are included: biotech on cultured or artificial tissue, immersive workspaces, cloud, decentralized web, generative adversarial networks, adaptive ML, digital ops, decentralized autonomous organization, nanoscale 3D printing, augmented intelligence, flying autonomous vehicles, transfer learning, emotion AI, light cargo delivery drones, synthetic data, knowledge graphs, personification, explainable AI. At the peak of Hype Cycle are edge AI, low Earth orbit satellite systems, autonomous driving level 5, edge analytics, AI PAs, biochips, 5G, graph analytics. Meanwhile, sliding into the trough are next generation memory, 3D sensing cameras, autonomous driving level 4. This slide shows about existing blockchain research works. 1. Applied cryptography, hashing, public key, key generation etc. 2. Peer-to-peer, peer-to-peer, consensus, sharing chunk data, transaction record. For example Merkle tree. 3. Security, 51% attack, transactions, gas, revert, error, late. Update, synchronize, small network, private and public, privacy or transparency, forensics enable. 4. Verification, formal methods, correctness, safety, liveness, deadlock. free, immutable, soundness, testing tools, nodes, network and smart contract. 5. Smart contract, programming, overflow, condition, call external, error, gas. 6. Computation, sequential transaction unblock, mining algorithms. Immutable update/fix bug. 7. Performance, transaction verification, sequential to parallel. This slide about blockchain application development. Creates/reveals/uncovers and new research work. This slide discuss about blockchain features. Blockchain offers 3 features to make back-office work more efficient. 1. Transparency. All documents, including contracts, compliance documents, and associated paperwork, can be placed in a central location, available to all stakeholders. Once these data are stored, it cannot be changed any further. Modification to the data will be recorded and visible to everyone. Data stored in blockchain can be shared with regulators in real time without any manipulation in between. This increases compliance, accountability and trust in the entire process. 2. Cost and time. In the oil and gas industry, transactions involving a wide range of work orders, invoices, and banknotes can be a huge challenge to manage. This complexity results in a lack of trust between the stakeholders, lack of transparency, and legal disputes over operations and data management, and delays in reaching and implementing settlements. Introducing blockchain to the system would help alleviate these concerns, reducing the money and time lost to stakeholder disagreements. 3. Financial transactions. When money changes hands, there is significant risk. Alleviating that risk costs money. Banks and intermediaries charge substantial amount of fees to act as middlemen in financial transactions. These third-party costs could be eliminated with the blockchain. A commodity-based cryptocurrency would make payments faster and more direct while also making them more secure. Blockchain-based smart contracts would release funds only after the terms of a contract were fulfilled. 4. Possibility application using Internet of Things. Lastly, you want to take or leave blockchain. Blockchain technology is still new and should be investigated with the mindset of how could blockchain technology potentially benefit us, rather than how can we make our problem fit into the blockchain technology paradigm. Organizations should treat blockchain technology like they would any other technological solution at their disposal and use it in appropriate situations. Thank you.